Okay, we are discussing properties of real numbers and we wish to develop the field of real numbers. By field, I mean, if suppose we are discussing real numbers today, what we need to do is we need to define addition and we need to define multiplication or maybe dot multiplication. Okay. So once we do these three things, I mean, what quantity that you want to do algebra with, presently we are discussing real numbers. Then you need to be aware of what is addition of two real numbers and what is multiplication of two real numbers. It is up to you how you define those operations, and based on the definition of those two operations, your field of real numbers will get developed. So, as far as real numbers is concerned, let A comma B be two real numbers. We assign an operation called addition denoted by plus. You can use any sign for denoting addition, but it is conventional to use plus sign denoted by addition, and the new number, and the new real number which is formed. Is A plus B. Okay. Now here, maybe you can have the wording little different, but the meaning I would like to say is this real number word is important here, because the meaning of addition, what do we mean by addition? If we have been given two real numbers, if they exist, we don't know right now whether they exist or not, some real numbers which are A and B, then we would like to associate a name or an operation. We would like to assign an operation to them called addition, and then it will look like this, but then this is different than A or B, or it may be same depending upon property or quality of A or B, but then definitely the new number that is being created, which is A plus B, is real number. Is real number. This is also called, I mean, this is definition of addition, and the property by which I am describing this is called closure property. Closure property. Addition of real numbers is closed. Meaning, suppose in a box or in a container you have two real numbers, then the container is closed. So you are creating a new real number called A plus B in the container. It might looking different than A or B. It might look different than A or B, but the new number which is generated is not going to come out of this box. This is the box of real numbers, and this is what we mean by closure property. The real numbers are closed under addition. Real numbers are closed under addition. Okay, so this is the first part as far as addition is concerned. Similar discussion we can do for multiplication. Let A comma B be two real numbers, we assign an operation called multiplication. Okay, denoted by dot, or you can use cross also, but we will prefer to use dot as multiplication symbol. And the new real number which is formed is a dot b. A dot b is also part of this container. Closed. Multiplication of real numbers is closed. Is it a correct English statement or not? I don't know. But okay, let me change it here. Real numbers are closed. Under multiplication. Okay. This is closure property. Closure property of addition, closure property of multiplication. And I think both of them are axioms that we have to start with something. Either a plus b is inside the box or a plus b is out of the box. A dot b is inside the box or a dot b is outside the box. That is what is the decision need to be made in the beginning. And naturally, if we are processing two real numbers, we are supposed to get a new real number. Therefore, we assume them to be closed. Now, you can take this down in your notes because this is not the part of what I want you to remember. So you can note it down from here to here. You have to remind me about recording. Okay. Now let us write down properties of real numbers. First property of real number is related to addition. Therefore, A1, let A comma B belong to R. A plus B is equal to B plus A. Okay. Addition is commutative. Take a minute. Addition is my handwriting has gone so bad because my board is not in line with my pen. Okay. This is the first property, which is very easy to understand. A plus B is always going to be equal to B plus A. But then what we need to focus on here is equality. What do we mean by two real numbers are equal? Two real numbers are equal, we mean they are the same, but their names can be different. So in this case, one real number is named as A plus B and another real number is named as B plus A. It cannot happen. The real number whose name is A plus B, his another name is B plus A. If this situation happens, then it is equality. So therefore, meaning of equality is the real number is same, but it is looking different. Its appearance is little different, but it is the same. It is the same real number. Okay, that is what is the meaning of equality. So whether you add B to A, whatever new real number that you will generate is same as if you add A to B. So this is our first property and addition is committed. Second property A2, let A comma B comma C belong to R. A plus B plus C is equal to A plus B plus C. Addition is associated. Okay. A3, there exists 0 belonging to R such that for every A belonging to R, A plus 0 is equal to A. 0 is called additive identity. Okay, so this is where you are generating your first real number called 0. If you add it to some number, the number remains unchanged, and therefore that particular real number which you add to another real number, the real number remains unchanged, is called additive identity, which is in our case 0. I mean, we will call it ZERO 0 and we'll denote it like this. Okay. A4. A4 says for every A belonging to R, there exists a dash belonging to R such that A plus A dash is equal to A dash plus A is equal to additive identity 0. A dash is called opposite of A dash is called additive inverse. A dash is called additive inverse and is also denoted as dash A, not minus A, but opposite of A. Okay, because minus is the operation subtraction which we have not defined yet, which we will define eventually. But therefore, you might have observed that every time I write minus 5, I call this as opposite of 5. So technically, more correct is opposite of 5. Calling this number as opposite of 5. Calling it as minus 5 is not, I mean, I will not say it is mathematically incorrect. It is not mathematically decent. Because minus is something you are supposed to subtract from something. That is what it has. Minus has some meaning in that. Whereas opposite is definitely, my opposite of 5 is opposite of actual plus 5. That is minus 5. Okay. So these are the 4 properties related to addition of real numbers. So addition is completely defined, or addition is completely understood by understanding A1, A2, A3, A4. And because of these 4 properties of addition, we got one real number with us, which is 0, which is this. 0 is there with us now. Okay, let us write down 4 more properties related to multiplication. Multiplication. M1. Let A comma B belong to R. A into B is equal to B into A. Multiplication is commutative. M2. Let A comma B comma C belong to R. A into B into C is equal to A into B into C. Multiplication is associative. M3. There exists 1 not equal to 0 belonging to R such that for every A belonging to R, A into 1 is equal to 1 into A is equal to A. 1 is called multiplicative identity. M4. For every A belonging to R, A not equal to 0, there exists A dash belonging to R such that A into A dash is equal to A dash into A is equal to 1. A dash is called multiplicative inverse. Okay. It is also called reciprocal of A and is denoted as A raised to minus 1. So these are 4 more properties of multiplication which are exactly similar to addition properties, except some important comments here. Okay, and that is why we say division by 0 is illegal, because this is what are the rules that we are writing. These are the laws that we are writing. And if we perform any operation where we divide by 0, we say that it is illegal because it contradicts M4. Okay, 9th property is D. Okay. Ninth property is D. For all A comma B comma C belonging to R, A dot B plus C is equal to A dot B plus A dot C. Multiplication distributes over addition. Okay, so using this property D, we will be able to resolve the bracket, remove the bracket, and distribute that multiplication over addition. So I am keeping this whiteboard on for some time, then I will stop share and then you take it down. Okay, once we are done with these properties of real numbers, the time is to prove few theorems. So theorem 1, uniqueness of additive identity. Additive identity is unique. So 0 in A3 that we have got is unique. We cannot afford to have more than one additive identities in the set of real numbers. That is what this theorem is all about. And we are supposed to write the proof of this theorem, because using these properties and whatever discussion that we have had about real numbers so far, we can write a proof for this statement, which is uniqueness of additive identity. Now, here, any other operation that we have defined in this lecture now, if you use, then that proof will fail, because we need to justify that action. For example, if you use this property, A plus B is equal to A plus C, therefore B plus B, therefore B is equal to C. We don't know this yet. This is left cancellation law of addition. Left cancellation law of addition, which is a theorem which eventually we will prove up in this sequence. So you cannot do anything like this. You are allowed to do only A1 to A4, D1 to M1 to M4, D, and maybe closure property or definition of addition or definition of multiplication or meaning of equality. These are the only things that you can have with you while writing the proof. I will wait for a few minutes and then write the proof of this theorem. Resume. Okay. By A3, there exists 0 belonging to R such that for every A belonging to R, A plus 0 is equal to A. If possible, let 0 dash belong to R such that for every A belonging to R, A plus 0 dash is equal to A. Statement 1, statement 2. Let A is equal to 0 dash. 2 implies let A is equal to 0. 2 implies 0 plus 0 dash is equal to 0. Let a equals 0 dash. 1 implies 0 dash plus 0 is equal to 0 dash. Statement 3, statement 4. We know that 0 plus 0 dash is equal to 0 dash plus 0 by A1. This implies 0 is equal to 0 dash. Contradiction. Therefore, additive identity is unique. Theorem number 2. Uniqueness of multiplicative identity. करा. Okay, I am not writing the proof of theorem 2 because it is exactly similar to theorem 1. Theorem 3 is uniqueness of additive inverse. Additive inverse is unique. Try to write the proof of this theorem now. A3. No, additive inverse is A4 implies, what is A4 saying? For every A belonging to R, there exists A dash belonging to R, such that A plus A dash is equal to 0. Correct? If possible, let there exists a double dash belonging to R such that, let me write down this commutative property here also. A dash plus A is equal to 0. Here A plus A double dash is equal to A double dash plus A is equal to 0. So now what we should do is A dash plus A dash is equal to, consider A dash is equal to A dash plus 0. कशामुळे A3 is 2, which is equal to A dash plus 0, नहीं, A dash plus A plus A double dash by 2. This is 1, this is 2 by 2. This is equal to A dash plus A double dash. A2, which is equal to 0 plus A double dash. 0 plus A double dash. A dash plus A is equal to 0 by 1. This is equal to A double dash by A3. A3. Correct? Contradiction. हाँ सर सिद्धार्थ हो येतात 3 वाजता हो चालेल चालेल नाही ॲक्च्युली मी मध्ये का वेळच मिळाला नाही हां हां बरं बरं चालेल 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 पाठवतो येस ओके ओके अरे आर यू डन A dash is equal to A double dash. That is possible. There exists yet another A dash we started. Here we should write A double dash is not equal to A dash, but that is understood. Okay, so this is uniqueness of additive inverse. Then we should have uniqueness of multiplicative inverse. Let me write down the theorem. I leave the proof to you. Theorem for uniqueness of multiplicative inverse. Exactly similar steps except addition, you will have multiplication, and of course that zeroness is important, that whenever you write A4 you should write that A is not equal to 0. Okay, next theorem, theorem number 5. I mean these are not the
Is it left cancellation law?
Theorem number 5 is left cancellation law of addition. Left cancellation law of addition. Okay. In maths, for every A, comma B, comma C belonging to R, A plus B is A plus C, then if then B is equal to C. Now you have understood how to write the proofs. You should try and write the full proof. Okay. Okay. Proof. Given A plus B is equal to A plus C. By A3 there exists A dash belonging to R. For every A belonging to R, there exists A dash belonging to R. Such
Or by A4.
A4.
by A4, by A4. Such that A plus A dash is equal to A dash plus A is equal to 3. Therefore, A dash plus A plus B is equal to A dash plus A plus C. Um, who will support this particular argument? Who will support this argument that I can add same number to both sides of inequality? Sorry, not inequality, equality.
A2.
A2, A2 is saying A plus B plus C is equal to A plus B plus C. That is not what we are doing here. Or are we doing? You meant to say like this?
Yes, so that is the next step.
Yes, sir.
No, this is the first step. Who gives us the permission to add opposite of A to both sides of equality?
A1.
A1 says A plus B is
Sir,
equal
by
to
the law of equivalence.
meaning of equality. Yes. This is some real number, say R1. Some real number R1 whose name is also A plus B and whose name is also A plus C. It is the same real number R1. A dash is yet another real number in the same box, and therefore addition definition allows us to do this. And meaning of equality. Okay, that allows us to say that you can add the same quantity to both sides of equality. It is going to be a new number, but two different names. Good. That means A dash plus A plus B is equal to A dash plus A plus C. Now this is your A2. Then 0 plus B is equal to 0 plus C. This is our by A4. This is therefore B is equal to C by A3. And the proof is done. Okay, good. We would complete because of your enthusiasm. We could complete 5 theorems.